సబ్స్క్రైబ్ చేయండి ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి ప్లీజ్ లైక్ అండ్ షేర్ చేసి కామెంట్ చేయండి.
Now we are going to discuss Newton's rings. Newton's rings experiment. The experimental arrangement consists of monochromatic source of light. This is the monochromatic source of light S. Convex lens L. Two glass plates. For example, this is the G1 and this is the G2. And plano convex lens. This is the P. The experimental arrangement of Newton's rings consists of monochromatic source of light, convex lens, two glass plates and plano convex lens, and finally telescope or microscope for using observe the rings pattern. Okay, first of all, in this experiment, plano convex lens P, the plano convex lens P is kept on a glass plate G1. Okay, let us consider the light starts from the monochromatic source of light S, falls on the convex lens L. From convex lens the light rays will become parallel, so the light rays starts from monochromatic source of light. Okay, these light rays will become parallel and falls on the glass plate G2. This is the glass plate G2. So this glass plate G2 is inclined at 45 degrees angle. So the light rays starts from S and travels through the convex lens, and they parallelly incidents on the glass plate G2. Then the these light rays bend with 90 degrees and incidents on the plano convex lens. These are light rays starts from the monochromatic source of light. The light rays travels through the convex lens and incidents on the glass plate G2, which is inclined at 45 degrees. The light rays are all bend with 90 degrees and incidents on the plano convex lens, which kept on the glass plate G1. A part of incident light rays reflected back. So the light rays are come direction this. These light rays are incidents on the plano convex lens. Then these light rays reflected back towards to glass plate G2. So these light rays are, for example, this light ray refracted in glass medium and transmitted and reflected and refracted and transmitted. Okay, same, these light ray in the glass medium refracted and reflected and transmitted. So then these two light rays are in superimposed, totally interference pattern is produced. Then these two light rays, thus the way all light rays are same phenomenon satisfy, then the light rays are all produced the interference pattern. That interference pattern as formed as the rings. Generally interference pattern is this type, bands, but in this experiment, particularly in this experiment, the interference pattern observed as the rings pattern. Okay, these are all rings pattern. So that's the way this experiment is called as the Newton rings experiment. Okay, how formation of the Newton rings, formation of the Newton rings formation of Newton rings okay, clearly observe the formation of Newton rings. This is the glass plate, this is the plano convex lens. So one light ray is incidence, then refracted, then reflected internally, transmitted, then internally reflected, and so these two light rays E and F, for example, these two light rays are in superimposed, then these two light rays are produced the interference pattern. That pattern is formed as a rings pattern. Okay, now we have to calculate the effective path difference. Another light ray, the path difference of these two light rays. So now we have to calculate the effective path difference. General effective path difference formula is the delta is equals to 2 mu t cos r plus or minus lambda upon 2. Okay, then this is the glass plate, this is the plano convex lens, and totally this area is the one film, air film. This is the air film. So this is the light ray, incidence light ray, this is the normal incidence. For normal incidence R is equals to 0. This is the air film. For air film refractive index is equals to 1. So finally the effective path difference delta is equals to 2 mu is the 1 t cos r means 0 degrees plus or minus lambda upon 2. Delta is equals to 2t cos 0 is equals to 1 plus or minus lambda upon 2. So the effective path difference is equals to 2t plus or minus lambda upon 2. 2t plus or minus lambda upon 2. Okay. So this is the interference pattern. This is the central ring. Why the central ring is the dark? Why the central ring is dark? For example, this is the air film. Totally, this is the air film. This is the air film. For example, this is the air film. This is the film. This is the film. At the center point, the thickness of T is equals to 0. The thickness T is equals to 0. So this is the something thickness T. This is the something thickness T. Okay. At the center point, thickness T is equals to 0. Then T is equals to 0. In effective path difference, delta is equals to 2 into 0 plus or minus lambda upon 2. Then delta is equals to plus or minus lambda upon 2. The effective path difference is equals to delta upon 2. This is the dark condition. So at the central point, the condition is the dark condition. So the central ring is the dark ring. Now we have to calculate the conditions of bright ring and dark ring. for bright ring condition, generally the effective path difference of bright general condition is equals to delta is equals to n lambda. Here our general condition is equals to 2t plus or minus lambda upon 2. Delta is equals to 2t plus or minus lambda upon 2. Here delta is equals to n lambda. General condition is that delta is equals to n lambda. n lambda is equals to 2t plus or minus lambda upon 2. 2t plus or minus lambda upon 2. Then 2t is equals to n lambda. 2t is equals to n lambda plus or minus lambda upon 2. Plus or minus lambda upon 2. So further simplification, 2t is equals to n lambda plus or minus lambda upon 2 is equals to 2n plus or minus 1 lambda upon 2. So for the LCM, 2 into 2n lambda plus or minus lambda upon 2, then 2n plus or minus 1 lambda upon 2, and 2t is equals to 2n plus or minus lambda upon 2. This is the dark condition. This is the bright condition. This is the bright condition for Newton rings. So we take the bright condition of general interference, delta is equals to n lambda. Delta is equals to 2t plus or minus lambda upon 2. Then n lambda is equals to 2t plus or minus lambda upon 2. 2t is equals to n lambda plus or minus lambda upon 2. Then 2t is equals to 2n plus 1 lambda upon 2. This is the bright condition for Newton rings. This is the bright condition for Newton rings. But this is the general condition is the dark. But in this particular case, 2t is equals to 2n plus or minus 1 lambda is equals to bright condition. Bright condition. Next, for dark condition, for dark ring, the general condition of the dark condition is equals to delta is equals to 2n plus 1 lambda upon 2. The general condition of interference for dark delta is equals to 2n plus 1 lambda upon 2. In Newton rings, delta is equals to 2t plus or minus lambda upon 2. 2t plus or minus lambda upon 2. Then these two equations are equal. That is equals to 2t plus or minus lambda upon 2 is equals to 2n plus 1 lambda upon 2. Okay. Then 2t is equals to 2n lambda upon 2 plus lambda upon 2 plus or minus lambda upon 2 plus or minus lambda upon 2. Further simplification, 2t is equals to plus or minus lambda upon 2. We have to take minus lambda upon 2 plus lambda upon 2 is the cancel. 2 is the cancel, n lambda. For the in plus or minus lambda upon 2, we have to take the minus lambda upon 2. Here, for example, this is the minus lambda upon 2 plus lambda upon 2 is the cancel. 2 is the cancel, n lambda. Okay. For example, 2n lambda upon 2 plus lambda upon 2, we have to take only plus lambda upon 2. So this equation 2t is equals to 2 is the cancel, n lambda plus lambda upon 2 is the lambda. Okay, 2t is equals to n lambda plus lambda. That means 2t is equals to lambda n plus 1. If n is equals to 0, this is the 2t is equals to lambda. If n is equals to 1, if n is equals to 1, 2t is equals to 2 lambda. Okay. this is the 2t is equals to lambda into n plus 1. If n is equals to 0, 2t is equals to n lambda. If n is equals to 2, 2t is equals to 2n lambda. If n is equals to 3, 2 is equals to 3n lambda. So the generalization 2t is equals to n lambda. We have to take minus lambda upon 2 n lambda plus lambda upon 2 is the n lambda. So the dark ring condition is the 2t is equals to n lambda. 2t is equals to n lambda. We have to clearly observe the conditions. Bright condition for ring is the 2t is equals to 2n plus 1 lambda upon 2. Dark is the 2t is equals to n lambda. This is the dark ring, this is the bright ring. Okay, this is the dark ring, this is the bright ring. But in generally, this is the dark condition for interference, this is the bright condition for interference. In particular case, in Newton rings, this is the dark condition, this is the bright condition. Okay, now we have to calculate the diameter of the rings. We have to calculate the diameter of the rings. Diameter of the rings. Purpose of the calculate the diameter of the ring. Construct the circle along the plane of convex lens. For example, this is the plane of convex lens. This is the plane of convex lens. This is the glass plate G2. This is the plane of convex lens P. For the purpose of calculate the diameter, so this certain part is the extension and construct the total circle. So this is the circle. This is the circle. This is the center point. This is the radius of the only radius of the circle. Totally this is the diameter of this circle, not diameter of the ring. This is the diameter 2r. This is thickness of plano convex lens. Okay, this is the thickness, this is the thickness, this is the small r, this value is the small r, this value is the small r. Okay, for the purpose of the calculate of the diameter ring. So some properties of circle, for example, this is the O, this is the A, this is the B, this is the C, this is the D. For example, properties of circle, that means this distance into this distance is equals to this distance into this distance. That means properties of circle, BD into DC, this is the P, okay, is equals to A into D, AD into DP, AD into DP. So this is the property of circle. This distance into this distance is equals to this distance into this distance. So BD is equals to totally this is the 2r, this is the T, this place is the 2r minus T, this is the T, this is the 2r, totally 2r, this is the 2r minus T, this part is the 2r minus T, totally this is the 2r, this is the T, 2r minus T. What is the DC? DC is the T. What is the AD? AD is equals to R, DP is equals to R. The total 2RT minus T square is equals to r square. Okay, then r square is equals to 2rt minus t square. If thickness is very small, that means t is very small, then t square is very small. T is very small, t square is very small, because if t is equals to 0.1, if t square is equals to 0.1 into 0.1, that means very small value, 0.01. So if t is very small, t square is very small. So here t square is neglected. If t square is neglected, so then this equation can be written as r square is equals to 2rt. Then from this equation, t is equals to r square upon 2r. T is equals to r square upon 2r. This condition for bright ring, t is equals to, already we know that t is equals to 2n plus 1 lambda upon 2. Here t is equals to r square upon 2r. Then r square upon 2r is equals to 2n plus r minus 1 lambda upon 2. Okay, then r square is equals to 2r 2n plus r minus 1 lambda upon 2. 2 is the cancel, remaining r square is equals to r 2n plus r minus 1 lambda upon 2. Here r is the radius of ring. Here r is the radius of ring. If r is the radius of the ring, then r is equals to d upon 2. This is the diameter of the ring. So in the place of r, we substitute the d upon 2. Then r square is equals to d upon 2 whole square is equals to r 2n plus r minus 1 lambda upon 2. So this equation can be written as d square upon 4 is equals to r 2n plus r minus 1 lambda upon 2. Okay, then d square is equals to 4r 2n plus r minus 1 lambda upon 2. Here d is equals to under root 4r 2n plus r minus 1 lambda upon 2. This is the diameter of the ring. This is the diameter of the bright ring. This is the diameter of the bright ring. Next, diameter of the dark ring. Dark. What is the dark condition? Dark condition is equals to 2t is equals to n lambda, but t is equals to r square upon 2r. Then here 2 r square upon 2r is equals to n lambda. 2 is the cancel, r square is equals to r n lambda. Here r is the radius of the ring, but r is equals to d upon 2. The half of the diameter is the radius. So this equation, substitute in this equation, then d upon 2 whole square is equals to r n lambda. This equation can be written as d square upon 4 is equals to r n lambda. D square is equals to 4r n lambda. D is equals to under root 4r n lambda. Then D is equals to 2 under root r n lambda. So this is the diameter of the ring. This is the diameter of the ring. So we have to calculate the diameter of the 16th, diameter of the 9, diameter of the 4, diameter of the 1. Alternative rings. We have to calculate the alternative rings. So D16 is equals to 2 under root r n is the 16 here lambda. D16 is equals to 2 into 4 under root r lambda. D16 is equals to 8 under root r lambda. So similarly, ninth ring D9 is equals to 2 under root r into 9 lambda. D9 is equals to 2 into 3 under root r lambda, that is equals to D9 is equals to 6 under root r lambda. So the difference between D16 and D9, D16 and D9 is equals to D16 minus D9 is equals to 8 r lambda minus 6 r lambda is equals to 2 r lambda, 2 under root r lambda. This is the spacing, this ring and this ring. Next, diameter of the fourth ring, that means D4 is equals to 2 under root r into 4 lambda. D4 is equals to 2 into 2 under root r lambda. 2 2s are 4. D4 is equals to 4 r lambda. Similarly, D1 is equals to 2 under root r lambda. The spacing between D4 and D1 is equals to 4 r lambda minus 2 r lambda, that is equals to 2 r lambda. This value is equals to this value. The spacing between any two consecutive rings, that means 2 under root r lambda, 2 under root r lambda. Now we have to calculate the determination of wavelength of given light, that means monochromatic source of light. Here sodium vapor lamp used as the monochromatic source of light. Determination of wavelength. Nth ring is equals to 4 r n lambda. Let us consider d square is equals to 4 r n lambda is equals to nth diameter. So for same n plus p ring, that means d square at n plus p is equals to 4r in the place of n plus p lambda. Okay, that means d square at n plus p minus d square at n, at equation 4r n plus p lambda minus 4r n lambda, that means 4r n lambda plus 4r p lambda minus 4r n lambda. Minus 4r n lambda plus 4r n lambda is the cancel. Remaining is the d square at n plus p minus d square at n is equals to 4r p lambda. 4r p lambda. From this equation, lambda is equals to d square at n plus p ring minus d square at n ring is equals to 4r p. 4r p. Okay. We have to calculate the refractive index. Generally, the plano-convex lens between glass plate, this is the air medium. Let us consider this space filled with the some liquid, the liquid has the refractive index mu. We have to calculate the refractive index. Okay, for air medium, d square n is equals to 4 or n lambda. For liquid d dash square n is equals to 4 or n lambda upon mu. But for air medium, d square at n plus p is equals to 4 or n plus p lambda. Okay, for liquid medium, d dash square at n plus p is equals to 4 or n plus p lambda upon mu. These two are air medium, these two are liquid medium. Okay, liquid medium. So now we have to calculate the differences of these two are, that means d dash square at n plus p minus d dash square at n, that is equals to 4 or n plus p lambda upon mu minus 4 or n lambda upon mu. Okay, that is equals to lambda mu 4 or n plus p lambda minus 4 or n lambda is equals to d dash square at n plus p minus d dash square at n. This value is equals to this is the mu, this value is equals to d square at n plus p minus d square at n. So d dash square at n plus p minus d dash square at n. From this equation, mu can be written as d square at n plus p minus d square at n upon d dash square at n plus p minus d dash square at n. This is the refractive index of the liquid medium.